Okay, so today we'll be focusing on a few of the things, especially we'll be focusing on backup processes and how we're going to maintain software backups or whatever the things. So one thing um, we talked about how we going to be creating the application. Okay, we simply started from a very simple application. Then we talked about how we gonna be managing the source code. Okay, how we gonna maintain the source code using Git and all those things. Then we talked about how we're gonna be working with distributing the application, especially when we are distributing the application. Uh, the modern way of distributing most of the web applications, software applications, is like Dockerizing it. Okay, so we talked about Dockerizing it, and we talked about how we can scale these things up. Most of the time, how we're gonna scale the applications that we have right now. So uh, there are other things you might ask. Okay, so when we're talking about applications, we basically talked about uh, web applications. Why do we train to learn on other application types? Like, of course, there are plenty of other softwares available in the market. There are desktop applications, there are mobile applications. So there are lots of going on. But in terms of in our course, we mainly focus on web application deployment. The main reason behind is that the shift towards getting most of the applications into web is high. Okay, so the trend is, yes, there are desktop applications, yes, there are mobile applications, but when it is coming to trends and things that we learn, the mobile application market is like, it's not shrinking, but the opportunities when it is coming to learn new things and teach you guys new things, it's a little bit less. So we will focusing on one set of streams that is going to be the web. And why we focus on web is so everyone is trying to get into web nowadays. Okay, so any desktop applications that you might have seen, they might be shifting to um, web-based ones. Okay, so that is common these days. For example, earlier days, you guys might have used things like word processing software, Excel softwares, or sheet management softwares. Nowadays, it's very rare. Even I myself, I do not have a desktop version of word processing like Microsoft Word, Open Office. No, I don't have that kind of things now. Nowadays, even if I want to open a document, it's easy. I open Google Docs or Office 365 doc, then I'm good. Okay, the main reason is it's easy to implement, like you don't have any special software to be installed and everything is happening online. So most of the time, the application is what we call software as a service is provided through internet. So most of the time when we are talking about applications nowadays, it's web. Obviously, it's gonna be continuing for a while. So we'll be learning along that part. Anyhow, you guys will be able to learn any other things if you go along. Okay, so there won't be a major shift if you are going into a mobile application development. All right, there will be like little bit here and there, but most of the time the concepts that we talked in here, the source code management, issue tracking, all those things going to be pretty much the same. Okay, so don't worry about source code management on mobile or any other desktop applications that you guys have seen. So the next thing we when we do look into web applications or mobile applications, there's certainly things we need to make sure that we have a copy, a backup. So why do we need backup in the first place? Why, if for example, we can have multiple things that we can back up within the system. Especially, we can have we need to have the distributed version backup. Okay, so for example, if I'm developing an application, a web application or something like that, I want to distribute it, right? I want to like make it compile and run it somewhere else. So when we compile the application, let's say, for example, a web application, we can create a Docker image, right? We will create a Docker image and then we can distribute it. Okay. And along with the distribution of the application, along with the distribution of the source code, of course, sometimes we will be using, like 99% of the time, we'll be using something like a database to store our information. So we need a place to store our data, and those database they should be in a safe place. Okay, so we need to make sure our data, which in this case, especially the database, should be backed. And there are other resources that we need to think about, especially when it is coming to what we call those things as assets. So for example, you guys might have images, sounds, videos, those kind of things we normally consider as assets. So we need to make sure the assets, of course, sometimes we have assets within the source code itself, like for example, images, logos, small sound clips, and those kind of things. Those kind of things, of course, most probably those things will be within the application itself. But sometimes there are like content that the user provides. For example, we are using some sort of social media application. So we upload our data, we upload our photos, we upload our videos. So those things should be kept somewhere, right? Those things should be placed somewhere in a way that those things are safe. So we need to back up user information such as those assets, our system information or user feed like databases, and we have the distribution. So all those things, three things should be backupped somewhere within the software cycle. Okay. So we talked about backing up at least three parts, but there are some things that we need to make sure that we need to keep a backup, but we need to make sure that it is not exposed to someone else. For example, if you're using an SSH key, okay, so we need a backup, but make sure the backup is safe somewhere that is trustable. If we get the SSH key to someone who is not within the organization, then we will be in trouble. Okay, someone can gain access to our system. So we talked about all these things. All these things should be kept as backup. So I might ask from you guys, why do we need backups? Okay, why do we need backups? So just give an idea, or just give me a few inputs from your end. Why do you need backups? Anyone? Yes. Anyone have any things? Why do we need to keep backups of our system? Yes. Avani, Pereira, Varuna. What do you think, guys? Why do we need to keep backup of everything in the scenario? So obviously, you guys have backup as well. I mean, not in this, maybe in the software system, but as well as your pictures that you take from your phone, your sounds or movies that you get, you need to keep those assets in a backup, right? You keep it in a hard disk or something like that, just in case. So what's the reason behind that? Why do we need backup in the first place? Yes.
Uh, so sometimes
Yeah.
Sometimes security errors or something happen and our data can be lost. In that
Mhm.
case, the recovery plan is somewhat important.
Yes, exactly. So when we are talking about systems, if something happens, um, if we get the most common case of issues will be a security related stuff. That's quite oftenly happen. So even though we think our systems are impenetrable, most of the time the systems they get what do you call they get hacked. Okay. Uh, so uh, so um so in a scenario like a security breach happens, so somebody else who have somehow gained access to our system, they might find, okay, there is this database, I will wipe it out. Okay, we will wipe out the database. Those things has happened personally from our experience, where when I was working on different projects, I got the same experience. So a lot of the time people come, they gain access and they just wipe it out. And sometimes they ask ransom. Okay, you need to pay this and this amount of money in order to get this up and running. This kind of thing happens quite often. So in a case like that, in a scenario like that, what would be our recovery plan? Okay, somebody wiped our database. Somebody took our data. Sometimes what we call these um, uh, uh, when we look into our applications, sometimes these people will come and say, okay, we need this amount of money now. You have no choice. Okay, so the main reason that we have assurance, if you are not able to pay the ransom amount, they might be asking a crazy amount of money. So in a scenario like that, how can we recover? The recovery process, how we gonna at least give when a data breach happen, how we gonna run our system without an error? So the only possible thing that we can do is restoring all backup. Okay, so most recent backup that we have taken, we can restore it. We can work, but uh, the um, the thing that we need to do is we need to make sure our users who have been using our system, they should be aware of, okay, right now there has been a data breach and it has been somehow altered, or they have like wiped out our database. So we might be losing some data, this kind of thing. We should inform them. Okay, otherwise they will be surprised. So when incident happens, such as data lost or cyber security attack, if we lose our data, what we can do is we'll be restoring a much older version, right? So for instance, the hacked or the data breach happened during 1 o'clock today. Okay, we might have a backup like 12 o'clock yesterday. So we'll be restoring the 12 o'clock backup. At least that is the most recent one that we have. So we'll inform the customer saying, hey, there has been a data breach. We have been affected. Since we have affected, we were able to back on application into this and this state. At least were able to recover up to yesterday's 12 a.m. Backup. So we are good, but we are investigating how we can get the rest of the data. So that's kind of information, that kind of thing will definitely help um, the users to get into like what happened and what sort of things it's gonna go. Um, Okay. Uh, so in a scenario like that, yes, once the data breach is happened, we should inform. So other things, why do we need backups? There are like damage to the system. Yes, that is also a correct answer from Pereira. Yes, sometimes this is when you're working in machines and everything. Um, yes, of course, we can't guarantee that hardware would run forever. Okay, sometimes hardware failures happen. Uh, you might have a, of course, if it is something like RAM or processor or something like that is not related to storage, okay, they might, uh, uh, we might have a good chance of recovering the data from the hard disk, and we will be good. Okay. So in a scenario like where we have a data failure, like a hardware failure, then we should be able to say, okay, we are having some technical issues with our hardware. We'll be coming back with the latest backup. In such a scenario, we can say that, and will be good. Okay. Yes, hardware failure, security breaches, and data loss. What do you mean by data loss, Sasindhu? If some data were lost, what do you mean by that? Of course, the backup is like to give us back some data, but what do you mean by if some data are lost? I need more clarity on how we're gonna lose data. Yes, one thing is security breach, other thing is like corrupted hardware. What are the other ways that we can lose data? Yeah, so those are like pretty much the common scenarios that we will have, and other things, including what we need a backup, is um, um, not on the hardware software side, it is also affect hardware and software, but sometimes we have like um, things like that we can't control. Okay, so for example, if a hurricane come and destroyed all our data backup, then what we gonna do? Okay, so there are like natural incidents that can happen. If something happens, then we might lose our data on such a scenario. Okay, so we need to make sure to mitigate the risk of losing data. We need to keep backup as much as possible. So the next question is, how we gonna uh, how we gonna take backups? What are the things that we will be using to um, what are the tools that we'll be using to take the backups? Anyone have any idea? What are the tools that we use to take backups? How do we take backups? Of course, if it is like assets, okay, like some photos in your phone, some documents within your laptop, you can just have a copy and paste, right? You can copy the directory or the files, and you can paste it somewhere else. So you have a copy, you have a backup of it. But in a scenario like where you have a database, how do you keep a backup? What are the things that you can do to keep a backup? Yes, anyone? Anyone have used any backup tools? Uh, yeah, so one answer is we could use cloud services such as Google Drive to store files. Yes, Google Drive is, if these things are like physical files, yes, we can do that. We can like copy and paste those data that we have created within from our machine to the cloud service. Yes, that is one way of doing that. Let's say, for example, we have a database. Okay, I need a backup of my database. So what is the solution that is out there that I can take a backup of my database? What sort of things that we can use to take a backup of my database? Anyone have used? Yes, anyone have used any tools so we can backup? Raise your hand if you have used any such a tool. Okay. Yeah. So basically, when it is coming to things like databases and everything, even it is SQL, NoSQL, whatever the type of database that we can be using, normally we keep the backups. We use database backup using something called dumps. Okay, so what we take a dump of the database and we keep it somewhere else. So for example, we have tools. We have tools that we can use to take is a SQL or NoSQL database dump. So essentially, what it's gonna do is we will have command line tools, or sometimes we have GUI tools, but most of the time we have command line tools where we have a specific application or a specific command that we can run and uh, get the backup. So it's going to be different from one database provider to another. So there is, I haven't seen at least a universal dumping tool where you can dump from a MySQL, Postgres, Mongo. I haven't seen, but there might be out there, who knows. But most of the time, under the hood, if there are such a tool, they will be using something like a database dumping tool that is provided by the database provider themselves. Okay, so if you are using MySQL, there is a MySQL dump command built into the client itself. Okay, if you are using Postgres, Postgres has a PG dump tool which we can use to take dumps. Okay, then we have MongoDB, those kind of NoSQL database. We have MongoDump. Okay, the list goes on. Um, so whatever the database provider, they will be providing us with the database backing up tool or dumping tool as well. So by simply executing a dump command, we can get the information, information backed up, as most of the time, the data that we're going to be backing up will be in some sort of way the database can uh, see or access. Okay. For example, if you take a database dump from a MySQL database, we can specify the format. Most of the time, we can specify the format the output should look like. Okay, we can take a database dump where the output file is going to be a zip file. Okay, so we will say the database client or the database dumping tool, hey, database dumping tool, there is a database at this location. So you need to you go and find this database, export this database or dump this database into a zip file. Okay, I'm just uh, telling in a way, storytelling way, but in real life, you need to type a command to do this. But anyhow, that's like the idea of it. So you command, you have to you will telling the application, you'll be telling that application, say, hey, we need to take a we need to take a backup in this format. Most of the time when we are doing SQL dumps, if they need to be compressed out, most of the time the database backups are like really huge. Okay, so yeah, if you are running a good, if you have a good amount of information, then the chances are you will have a huge database dump. Sometimes we find database dumps like in smaller size, 2-3 GBs. That is like the smallest form of database dumps. Of course, it depends on what you are collecting. Okay, so one of the most lowest application, most of the time when we are developing an application, the lowest size that I have seen is 2 or 3 GB. That is like the smallest form as I have seen. Okay, but there are some applications which the database dump would be in not in megabytes or gigabytes, sometimes in terabytes. Okay, so these backups that uh, that we are taking quite tend to be um quite tend to be like huge in size. Okay, so if you take a backup in their plain form, what will happen is the size is going to be little bit higher. So for example, if you take MySQL database backup without any compression, normally it would be outputting the dump as a SQL file. Okay, so we normally if you take a database dump without any compression or something like that, the file is going to be an SQL file. So if you open that plain SQL file, you will find a lot of create database sections. Sometimes if you only export data, you will see insert into this and this kind of commands. So when we are taking the backup, what it does is it convert the data into insert into or inserting SQL queries. So when we are creating those queries, when you are exporting those queries, a lot of things will be duplicated. For example, insert into, that is something gonna be that's gonna be something all over the place. Because if you are inserting into a one single row, and the values, they might change. So anyhow, when we are taking a backup in a raw format, the example that I have taken in SQL is SQL file output. When we take a SQL backup, it will be huge in size. Okay, to avoid these things, we normally compress these files. So loosely some compression tools like compression formats like zip or 7-zip, gzip, whatever you can find it. It's better to uh, make the backup in a more compressed format, because uh, based on the amount of data that you're going to collect, the backup will be huge. Okay, so make sure when you're using a tool, when you're using such a tool, get the database backup as much as uh, compact as possible. Okay, that's kind of a way to save your data, have more backups. So the dumping tools, they normally provide these options where you can select if you have some desired output format, maybe that will convert to that format as well. If they're not, of course, probably you need to manually at least compress those files and delete the original backup file. If it is, say, for example, uh, the, the dump that we have taken is SQL file, and that SQL file is getting larger and larger, make sure we do a compression and we use the compressed version in such a case. Okay, so database dump tools are everywhere, so you can use those too. And so let's see some of the dump tool that we have, at least at the end of the lecture, like Mongo dump. So we can take a look into the dumping tools where we can take some smaller dump and see. So as I mentioned, the files, the dump that the dumping tools will provide is going to be different. SQL database will have a .sql file, and MongoDB in one of the NoSQL database. If you're using MongoDB to take our backups, so the backup will be either in a format called BSON, okay, BSON, or there can be a raw format like JSON. Okay, so we can either take a JSON output or BSON output. So in that way, we know for sure that it is going to be working as expected. One other thing that you need to worry about when you're taking backup, the frequency of the backup. How much frequently that you need to take the backup in the first place. So normally it's there is no like written statement or some sort of rules that specifying how frequently that we should take uh, uh, how much frequently that we should take database backup. So there are certain limitations when it is taken into backup consideration. The most of the time when we are taking a backup, what we need to worry about is when if you are taking backup very frequently. So very frequently in the sense it is depending on the context. Okay, so let's say we take backup every let's say every hour. Okay, every hour we take a backup, and within the day, so we'll be end up with 24 backups. Okay, so you guys, as you guys can think, most of the time database are appending data. Okay, it's very rare that in a system we delete some data from a database. That is like very hard or very abnormal thing to see in system most of the time. Unless you are pretty sure that this document or this information is no longer needed, we will be deleting. But most of the time, we keep the deleted data even in a different state. So sometimes later on, we need to look what happened. So if we delete it completely, we don't have any reference to that. So in order to make sure that we do not completely delete it, what we do is normally we keep a we keep separate status that we say, okay, this record is deleted in deleted state. So you don't have to take this into consideration. That kind of thing. So when we are then what we need to do is uh, in application like what we have, taking that amount of backups, like 24-hour based backups, then we'll be adding few data. So for example, at the starting of the backup, the first backup that we're taking, it was around 1 GB. And within that 1 hour, let's say we added like 5 or 10 megabytes, then the second backup would be little bit higher. So at the end of let's say at the end of the day, we completely add like 500 megabytes worth of data. Okay, it depends. Okay, I can't predict these things. So what will happen is the size is gonna get little by little increased. Then we have like 24 gigabytes of worth backup per day. Okay, so we need to make sure if it is a critical system, if it is like a very critical system, we can say yes, this is a critical system that we need to keep these information as uh, as much as duplicated possible, yes, then we need to uh, keep those backup. We for even even if the cost is high, yes, the cost of keeping those backup is gonna get high, but the other part is if we get sometimes if we get attacked or something like that happens, how how much data that we can go previously and provide uninterrupted service, or maybe how much damage we can reverse. So that's depend. So yes, we can take backups each and every hour, each and every day, whatever suits for the system, how sensitive the information is, how much that we can um, uh, how much we can um, um, how much we can spend on the backups. That's depending on all the things that we talked in here. So in a scenario like when we think about the size of the backups and everything, if it is worth, yes, we should keep it. Then the frequency that should be adjusted based on your requirement, based on how sensitive information is. So you guys can guess that there is no specific answer for those things. Okay. If you can justify your changes, then that is okay. And there are sometimes when you're taking backups, there are like mandatory security, or sometimes the backups is enforced by the system itself. Okay. As I know, the telecommunication providers within Sri Lanka, they need to keep every information backed up on their servers for like 6 months prior to today. Okay, so whatever we do today and 6 months backwards, those things will be back up somewhere in our in the service providers database or somewhere where they keep their information. So the main reason is if something happens, like let's say for example a court orders gives us okay, we need some information weighing back 2-3 weeks, then the providers, they should comply and give those information. They can't say, okay, that was something in the past, we only have 1 day worth of backup, we do not keep everything. So you can't escape that. Okay, if the law mandate, you should keep those things in hand. Okay, I'm not sure the correct period, is it a month or 6 months, but anyhow, sometimes law mandate to keep track of how much data that we keep. And that points to the next thing, what we're going to do with all backups. Okay, do we need to keep all backups? How long that we need to keep that backups? Okay, as I mentioned, if there is no uh, law mandating within the uh, organization operations, then it's up to the organization to keep on how much backup that we gonna keep. Okay, how long that the backup would be supported. For example, if we have uh, if we have a system, if you have a system where uh, we generate information, and the backup would be something like for 7 days. Okay, so what we do is after 7 days, we delete all the backups which were much older than 7 days. Okay, so we do not need to keep those backup. It's not going to be only the database as well, but sometimes um, when we are deploying applications, the older versions, sometimes we also delete those things. So no longer it's going to be there. So that's kind of things happens. Application backups, we do not keep sometimes assets backup. If they are like too old, if the system is no longer using them, then we might need to remove those things. The special thing is that especially when we are working with the databases, yes, database backups are the most important. We need to keep in mind that database backups will be like, okay, I would say like this backup should be like we are keeping backup until 7 days. That's kind of the policy provided or given by the organization itself. So if organization is giving us what we call backup period, then we should honor that as well. Okay. So after that, if there is no law mandating, we can simply delete those things and we can get rid of all the backups. Okay. So we can't keep all the backups forever. Okay. Eventually, someday when we are getting out of space, if we say if the servers are no longer having a lot of space, what we need to do is we need to get rid of those backups. Okay, we will keep away the system. We keep the backup system separately. So next thing, the next question is, where are we gonna keep our backup? Okay, where do we gonna keep our backup? So one of the stupid things that even I did when I was starting as a person who is new to the industry, the backup and the system, the both were in the same machine. Okay, so we had the machine. We take SQL. We had a database. So we take the SQL. Right. We take the SQL backup and we keep the SQL backup in the same server that we were running the application, or sometimes in the same database server that we are running. Okay, so what happened was one time we had an issue that was a failing hard disk. Okay, the hard disk was failing where the database server was running. So luckily we were for some reason it was happening in like non-working time. So we were able to get a backup just in case without losing anything before the hard disk went down. Okay, so when you are taking the backup and we are storing it, make sure you do not store it the same machine that you are keeping the backup as well. So the main reason, obviously, you can see that if something happens to that machine and the database backup goes with it. Okay, so you don't have the system, you don't have the backup, you have nothing. You have lost everything in a scenario like that. So make sure when you are running backups that it does not contain in the same machine. Okay, then another thing another thing that can happen is, okay, we are not keeping in the same machine, but we are keeping in a separate machine. We are keeping the backup in a separate machine within the same network. Okay, within the same network, we have another machine which keep all those backups. So what we're gonna do is we will back up all the information that we got from the system into a application which was running on uh, which is a backup server which is running on the same network. Okay, so we do not keep the backup in our local machine or local where the system runs. We keep the backup in a separate machine within the same network. Okay, so obviously when you think about it, when you look into the fact, what will happen, what would happen if somebody attack the network itself? If somebody takes down the network, or sorry, attack the system in a network level as well. If somebody get to the access for the whole system, then what will happen? Okay, so if the system within the network is goes down, when you are working, your application is you are taking the dump and your dump is on another server, then you get hacked or you get a security breach. Yeah, get your main database down and the backup servers are also down. Okay, so there is no way to retrieve those data if the network is going down. So that's going to be a problem. Okay, so yes, obviously, it is much safer than keeping in the same machine, but having a database backup in another machine probably improves the probability of getting or losing your data. But it doesn't help the fact that it can or it will get affected as a network as a whole. Okay, that can happen. That would be something we can that would be something that we can expect. Okay, so how to overcome these kind of things? How to overcome this kind of thing? What are your suggestions, guys? So we can't put it in the local machine. You can't put it in the local network. What else? What else that you guys would take to keep the backup? What would be ideal place? What we where do we, so we have a backup server which will be in the net within the same network. Yes. What do you and what do you where do you keep a backup? Yes, anyone? So within the same network, same network, different machine, we can keep, but there is a risk. There might be a risk involved, but in a scenario where we do not, where we have a backup and we want to keep it safe, where do where will you guys be doing that? Yes, your suggestions. What are your suggestions? Yes, anyone? Kumudi, Varuna, Sumira, Sumira, I think. Ethan, Ethan. Yes. What are your suggestions? Yes, come on, guys. Talk. Asika, Arindu. Yes. Anything? Any place that you would find to keep a backup? Okay. So in a case of we have uh, in a case of where we have multiple uh, data centers, what we can do is rather than keeping all our data within one single data center, we would transfer it to another data center that we have. Okay, so for example, I have a backup server where I live. Okay, I'm living, let's say, I'm living near Mathale. Okay, so I have a data center or I have a backup in Mathale. What I will do is I will keep another backup, another data center, which is in Kandy. Okay, that is something close by. So what I'll do is I will put everything that I have in my local machine. In my local data center, which is in Mathule, I would put that in Kandy. Okay, so rather than depending on one single network, we have another backup location, backup storage. Okay, so a data warehouse is not like should be in one single place, but in two different geographical locations even. Okay, so the ultimate ultimate thing. So for some reason, people who are in Matale and Kandy, they got cut off to the network, and if something goes wrong, then what will happen? Okay, so if he can't manage it via the district level, at least geographical district levels, then what we can do is we can keep these information in more broader data center. For instance, I can keep one data center, one backup in Sri Lanka, the other one is in Europe or somewhere, something like that. Okay, so it makes more sense to me to have my backup spread around the globe, okay, as much as possible. So in that way, if something happens within some given area, we are at least we have some uh, good way of recovering it. Okay, and remember, this is all depending on how much you can spend on your backup and how much the information worth. Okay, so keeping these backup strategies in mind, we can always think about the application where these things will be uh, put in. Okay, the location matters. So where the main operations happens, it's easy to keep a backup where it is nearby. Okay, the nearby one. So for example, if I live in Matale and um, I need uh, I need to restore a backup. Okay, rather than take it in from another country. Let's say my other backup is in UK. Okay, so rather than taking that backup from UK, what I can do is I can take the same backup which is in Candy. Okay, obviously it will be much faster because we are in like approximately um, we are in the same proximity, so it will reduce the time that it would take to restore the backup. But anyhow, it's depending on the infrastructure and all those things. But theoretically or in practical life, it would be easy to get me to get a database backup from somewhere local rather than somewhere foreign. Okay, so that is one thing that you need to remember when you are keeping a backup. Yes, the diversify that you can get, the more places that you put your backup, the more safe you are. But again, it's for some things like how much um, how much time it will take to restore and everything. Okay, so all of now that we have talked about is something like creating a backup. Okay, we take a backup of the database and we are spreading it around. Okay, and one other thing that we need to think about when you're taking this when you're taking a backup is uh, yes, how secure the backup is. How secure the backup is. So, for example, we can take a backup and we'll keep it in our local network or something like that. But for some reason, if somebody get sorry, if somebody gets access to the database backup, say for instance, they were able to sneak in a pen drive and that pen drive could be copied the database, and someone goes outside and say, okay, I have the database of X company and everything that was there, I have those information. And if there are competitors, they would be love to have those things, what are the information that they have stored so far. And sometimes people explore these databases just to get information out of things. Say, for example, they might contain custom information, sometimes card numbers, sometimes email, sensitive information such as um, chat history or credit card numbers, those kind of things. All those information will be there if those things are put it in a backup. So how we can get rid of how we can make sure our backup is safe. Okay, our backup is safe. Yes, I need your answers, guys. How do you keep the backup safe? How do you make sure the backup is security wise, it is safe? What are the things that we can do? Yes, any ideas how we can make our database backups more safe? Any ideas, guys? Varuna, Pereira. So how do you keep these backup very safe? Of course, anyone can take it. I mean, at least who have access to the backup and everything. So how do we keep the data secure? How do we keep the database or any backup secure? Now, what are the things that we can do? Yes, Tarushi, Tarindu, what are your inputs? Yes. So obviously, when we take backup, yes, have a secure encryption on the backup. Yes, that is one option. We can have encryption. We can encrypt our data. We can encrypt our database backup. So sometimes what we need is we need to encrypt the whole database backup. Okay, so the whole file or whole dump would be encrypted in a way, encrypted in a key that only the authorized parties can decrypt and see. So that is one way of uh, doing one thing that we can do to keep our data safe. What are the other things that we can do? The other things that would do is not every yes. The other one is like store backup in a multiple locations, but again, Varuna, that does not guarantee the safety. Yes, but the safety in the sense security wise, that doesn't guarantee if we have multiple locations. What I'm asking is we have a backup and we need to make sure the data within there is well kept hidden. Okay, the data is always what matters the most. Okay, so we need to keep that data secure. So if you have multiple locations, that is something what we call redundancy. Okay, we will increase the redundancy. In a redundant case, if we lost the data, yes, we can back it up, but how do I make sure my information is not the backup that I'm taking is well kept, my data is protected. So having it in multiple locations does not help to secure my data, the uh, uh, secure the information is going to be leaked, or the backup will be exposed to the general public. That I can't guarantee by having in multiple locations. Yes, but encryption is true, one thing. If you have encrypted your database backups, then no one, unless the authorized parties can look into that. Once you decrypt the file, then you will get the information back. So in a scenario like that, yes, encryption is one that is also true. Another mechanism or another thing that we can do in order to make sure that our application we haven't encrypted anything, but the other thing that we can do to secure the data is to have user roles defined. Okay, by defining user roles, what will happen is only authorized users, Okay, only authorized users will be able to take backup. Not everybody in the system is able to take backup. Only authorized people should be able to take backups. Okay, for example, a typical day-to-day user would be only accessing information like getting information queried out, like 10 records, 100 records, 1000 records. That's the maximum. But for a backup user, they need to access the all information, all the databases and all the tables at once. Okay, so in a scenario like that, we can restrict the users how they can access the data. So normally in a backup system, in a dumping tool, we create a special user with special permission that they are the only one who can take a dump. Not everybody in the system can take a dump. Other, if somebody breach our system using using information they gain from a normal user, they can only take few records at a time. They can't take the full backup at once. Okay, that is one thing that we can do to make sure we have separate users, separate user roles who can take dumps and who can take dumps. So only those authorized people would be responsible for taking the dumps. Okay, so that is one way that we can secure the data. So others, even a malicious attack comes in, we have some sort of protection against that. Okay. And what are the other things that we can do? So yes, encryption is there. Then another one clever thing that I have seen is we keep the data within the database itself in a ways others can't understand. For example, say for example, we have the usernames and passwords within a database. Sometimes what we can do is, rather than keeping the data in a raw text format, okay, so, rather than keeping the data in raw text format, what we can do is we can keep the information in a unrecognizable way, like a hash mechanism. Okay, so if you guys know hash mechanism, so it is it's not actually encryption. Hashing is like we take our data, we use a hash algorithm, and we create a unique output. So we can store the information, but only the people who have the correct hashing mechanism can read it back. Okay, the I mean, obviously when we hash something, we can't like retrieve that information back. Okay, so for example, one thing I would give you guys, let's say the password. Okay, I want to store user's password and email and the password. Let's say we want to stay email and password within the database. So how do we normally can do? How we can normally do is we can store the information within two columns. I'm talking in SQL manner, but same goes to the other NoSQL ones as well. But in a place where I want to store the information, what I can do is I can store email in plain text and password also in plain text. Okay, so someone who have gained the access, if you're having the plain text password, what they can do is they can easily copy paste the username and password. They can access the system. They can do anything with the system. Okay, so if you have plain username and plain password, that would be a risk. Okay, the other thing that we can do is what we call what we introduce is what we call hashing. Okay, so when we are doing hashing, what we can do is normally we take the information, we take the password, and we using a hashing algorithm. What we do is we hash the input. Say for example, we get the user's password in. Rather than plainly storing it, what I will do is I will hash the password using a hashing algorithm such as there are like a lot of SHA-25, SHA-512, whatever the hashing algorithms that is available out there. Using that algorithm, I would hash my password. Okay. Once I have hashed my password, it will be stored in the database rather than the plain one. So anyone who's coming to the database, let's say, for example, a security breach happened, they will find the username and the password is not in plain text, but it is in hash format. Okay, so they can't recognize the information. Okay, the hash password. Even if they try to input the hash password as the password, then it won't work. Okay, so in a hashing mechanism, what we normally do is if we want to compare that value, we again take the user's input. Okay, let's say let's get the user's password. We hash it again and we match the values which is in the database is the same. Okay, so let me give you an example on that. Let's say my password is Spider-Man. Okay, my password is Spider-Man. And once I hash the password, it is going to give, using a hashing algorithm, it is going to give weird, based on the length of the character, based on the hashing algorithm, it's going to give random characters within my um, to my password. Okay, so the Spider-Man, I hash it and I get a random character string that I can store in the database. So I store that in my database, the hash password. So if somebody comes again and I want to make sure the password is matching, I need to match the password sometimes. Okay, when we are, say for instance, we are creating a login system, we want to make sure the password is matched. Okay, we need to sure the password is matched. So if I enter the same password with the same algorithm, it will give me the exact hashing number. Okay, the hash output. If I change one single letter, one single bit in my um, password, then a completely new hash will be generated. It won't be matching the one that I have in the database. Okay, so that's how we keep the information such as password or sensitive information in secure database. So we really don't store the plain password, but instead of that, what we're gonna do is we're gonna hash the password and we're gonna store it. Once we want to match it, once we want to uh, see the value that the user have input is the same, we're gonna take the same password, hash it the same algorithm that you use, and see the output is matching what we have in the database. So that's how we can use hashing to secure our data. So if a database user take this information and they try to exploit the password using the algorithm, so they can't even use that. Okay, so you guys might ask, okay, if for somehow uh, uh, somehow if somebody gets the hashing algorithm, okay, I have the hash password, and for some reason there is not going to be like plenty of hashing algorithms out there, or we can brute force it. We can use the hashing algorithm and try the guess password and see whether it is matching. Then it should give me the matching thing, right? So I have the guess password, I have the hashing algorithm, and I have the hashed. So all together get together, and I can reproduce the password and check whether it is matching or not. Okay. To prevent this, we have something in hashing algorithm called a salt. Okay. So I'm not gonna go that much deep into the encryption and all those things. Probably you guys should know by these things now. So we use something called salt. So using the salt, we make sure even the algorithm, even though we know the algorithm, if you do not know the salt, then no one else can see the information back again. So we have something called that, just for your information. Okay. So we were talking in backup strategies. Yes, we can secure the information by completely encrypting the database backup. Or sometimes when we are taking the backup, we need to hash some sensitive fields. So anyone else do not have the hashing algorithm and salt, they can't decrypt and see this information. The other thing that most of the time the application security wise, what we can do is we can sudo anonymous the information, okay, rather than completely giving my email address and everything. If I have a sudo anonymism, that means I am identified by someone, a number or something like that. I don't have any personal information where I can track down the information. Then I will be pseudo anonymous. That means the information cannot be traced to me. At least that is something that at least that is something that we can think if such a backup or security risk happens. We do not leak the information of the users. Okay, that is something uh, good rather than losing everything. Okay. All right. So backup, we need to think. We need to think in a way that where we keep these backups, and we need to make sure those backups are safe. Okay. All right. Next thing. So we talked about backup strategies, backup frequency, backup security, and one other thing that we need to do in a case of having having backups and everything is that we need to um, we need to we need to make sure um, when we are restoring this backup. Okay, the backup is useless unless we can restore it. Okay, the restoring process is not quite complex. Okay, we can't have a backup that is taking forever to restore. So normally when we are restoring the backups, we need to make sure it is not taking a long time to restore that asset. Okay, so that is one thing, restoration process that should be very fast. Okay, all those things that right as of now we talked in, we are taking a dump. Okay, we are using a tool and we are taking the backup. Okay, and there are other ways. That we can make sure our application is backed up in a proper way. Okay, so we all this time we talked about we all talked about the thing we all think about taking a backup and restoring it once again. Okay, so another way of, it's not like taking a backup. It is like a sort of way that we take a backup, but in another way it is more into like what do you call that, keeping data all the time available. Okay, that's kind of thing. So like rather than I'm not using the word backup in here. So most of the time when we're talking about a backup, we get the idea of, okay, we take a dump and we keep it somewhere else. Okay, the other way that we can make sure that the application itself is what do you call more more resilient for any failures. That's the correct word, I think. More resilient for um, more resilient for any failures that can happen is yes, one way is keeping backup. The other one is this is probably more into like um, more into like keeping backup, but as well as keeping high availability. So what is the strategy that we can take other than backups is what we call replication. Okay, replication is sort of a backup, but it is like not something that we do in using a special tool like dumping and everything, but by simply replicating. So what do we understand by replicating? Okay, so we can replicate databases using special softwares, what we call those things as clustering softwares. We call these things as clusters. Okay, rather than having one single database, we can have a cluster of databases. Okay, so ideally the cluster of the database is gonna act as one single database, but for some reason, if one of the clusters node, we call one single instance within the cluster a node, for some reason the node goes offline, what will happen is the other nodes within the cluster will move on. Okay, they will work as expected. So for instance, let's say we have a cluster of a database where we have three instances, and all those three instances would be doing the same job, running a database. Okay, so they don't have like different things happening. Okay, they will be only focusing on having a simple database running, and we will be interacting through those three nodes, the same database nodes, as one single database, not rather than like three databases. We have one single database. So in a scenario like that, the concurrency or the availability of the database is high. Also, we get a free kind of a backup system. Okay, it is not like physically taking a dump, but rather than going down with anything else, we have three nodes or whatever the amount of nodes that we have, and all these databases within the cluster are synced together. So let's say we have three nodes, node 1, node 2, and node 3. Whatever happens in node 1 is known to node 2 and node 3. Okay, so if I insert a query, if I execute an insert query, all those information, the information that I inserted into the document, inserted into the database, will be replicated, will be available on those three nodes. Okay, I work or I interact with the application as one single database, but within the cluster itself, what will happen is the database is considered, or the database is acting as three individual nodes, and three of them are within sync. Okay, whatever the database change that I do within one single database is affected on the other one as well. So we don't have to worry about taking backups and everything. Okay, but time to time, that doesn't mean we should not take any backups from the cluster. We should, but at least the backup frequency that we need to take can be reduced, since we have three backups within the cluster. Okay, so the cluster synchronization happens. The cluster knows how to send data from one node to another, and keeping up to date, that is done by the cluster itself. So we kind of think we can think it as like three backups that we have. If one goes down, the other two will manage. Okay, and for instance, we introduce a new node. We introduce a new node to the cluster. What will happen? All the information that is uh, within the um, within the node or within the cluster will be in sync. Okay, so if I add a new cluster, what will if I add a new node to the cluster, the new node will get all the backups from the other nodes, and it will be synced up to date, right up to what we have. Okay, so there is some way of having a backup, but it is not like something like taking a dump out of the database. Okay, but something that you guys should have. Mm, okay. So we talked about dumping mechanisms, dumping how we can securely store these things, uh, how we gonna make how we gonna decide the frequency, how sensitive information are shared, and what we can do with clustering to make sure the database and everything is secure. Okay. Right. So this information that I have talked is like anyone can make these things, right? We can create backup systems and everything, keeping all these things uh, um, um, making these backups and keeping everything up to date. Everything is like there is a little bit task involved into it, right? There is a little bit of things that we need to do in order to get these up and running. Okay, so there should be like things that we can that we can uh, that can make this process little bit easy for say. Okay, we can little bit make this process easy. Okay, so in order to take these things up, in order to make the application backup process and make sure we do not lose any data, or we keep the high availability and all those things. So there are like certain things that we can do, the certain applications in this special scenario. I'm talking about the database instance. Okay, so there are like database management system, DBA database systems that we can use in order to in order to I think I am sharing the wrong screen. This one. Yeah, there are like specially dedicated software that is built to do such things. One is these, I'm taking the AW example as one cloud provider, but there are other providers like Google, Azure, DigitalOcean, whatever. Most of the cloud providers have these kind of solutions where you don't have to, like, you don't have to take backups by yourself. You don't have to take snapshot of the application of the database. You don't have to sync those things. You don't have to worry about losing data. So everything that we talked in today's backup in studies and everything can be achieved something like this AWS or RDS, okay, relational database management. So most in here you will find a lot of databases. Okay, it's not like all the database are in here, but most of the time the Amazon RDS these supports SQL, NoSQL, sorry, no, SQL database RDS normally. It's going to be supporting these things, and there are like simple options where we can just simply say okay, uh, uh, by simply we can say we can take this database system and you do the managing part. Okay, when you are managing all these things, when you are doing these management things, you don't have to worry about those things. Okay, so take a look at these RDS things as well, so you guys know what's going on in here and what sort of services that they provide. And what sort of things that you can expect from the application management, database backups and everything. So this is only for database. Of course, there are solutions for other assets as well, such as the assets like images and videos that we talked about. So uh, we have these things in other services as well. So we have in Amazon, we have something called S3. Okay, Amazon S3 buckets, we call them. So we can keep the information uh, in more blob data. We call those things blob database, or this assets such as images and all those things backed, and you don't have to worry about things. But obviously it comes with a price, but it's going to drastically reduce the pain that we have to bear. Okay. Okay. All right. So I'm gonna stop the recording.